In the mid-1990s, there was a popular consumer operating system called Windows. Notoriously, it would often crash, displaying a screen of text. The screen was blue. Now think hard. We're talking about the blue screen of death. You're right. You all got it very quickly. I mean, we must have some real computer history aficionados in the room because it's been decades and it's still top of mind for you. But actually, since I knew there would be some aficionados here, I had to do an experiment, right? Because I asked hairstylists and administrative assistants and teachers and nurses and various people, some of whom I don't think were even alive at the time. Every single one of them, without fail, just as well as you, recalled, oh yeah, death, that's the one. I want to point out for historical accuracy, that was not the official name in the manual. That was what the public universally decided the screen was called. Not one that I talked to called it the blue screen of inconvenience. Why is that? Because software should work. Columbia, Missouri, it's good to be home. I've been developing software for quite a while. I've been a tech lead in 4 industries. I've worked on some stuff you may have used, including where I started my career at Carfax.com, right here. I actually pushed the build that first put the Carfax mascot on the homepage. Fun fact. And most recently, I was part of a coding agent startup that's an open source coding agent called OpenHands. My title was Chief Architect. I'm currently on a project called the Coding Agency. Now, we are gathered here today to philosophize about the fact that software should work. Great thing to be doing. I think there's at least 2 things that even the last word of that means. It works as intended, and it works for us, right? It works for the users, for even society, not just does what the developer and their employer might have intended. And when we talk about the blue screen of death, it is very much of the first kind. Like, the computer was in the process of doing something the user did want to do. That was the problem, right? They were annoyed that it stopped doing that. But now we have innovated on bugs to the point where even when software works as intended, it is often doing things nobody wanted it to do in the first place. Now, we could talk about a lot of systemic forces. I think there, are some at work bringing out about a new level of onslaught on really both of these fronts. And if you think I'm about to mention AI, unfortunately, you're right. But I also want to introduce another concept here called a software quality crisis. Just personally, how I model this. A software quality crisis is not just IT's problem, right? We live in a frequent state of crisis, and it is important. Our judgment on that count matters. But ultimately, because we are kind of a line of defense, stopping the problem from escalating further, we will be feeling a crisis more often than the general crisis that I'm talking about when I say that something rises to a crisis. So this conversation, I'm talking about it's not just IT's problem. A software quality crisis is one that is everyone's problem, right? It is the C-suite's problem. It is the market's problem. It rises to a level where we have lost public trust, and that has a huge commercial impact, among other impacts. So when is it a crisis? So I'm going to at least give you a very simple metric on when I say we might be looking at a crisis. Just very simple litmus test. It's a crisis when my hairstylist knows about it. They're not supposed to know about our crises, right? I was talking to my hairstylist recently, and they asked, as you do, what are you doing lately? And I said, well, what I do is study ways of preventing software bugs. And she said, oh, are the bugs because of all the AI? Red flag. She should not know this much about what I do. And this is actually what in marketing they call unaided awareness. Because if you think of tissues, you think of Kleenex, right? If you think of vehicle history, you think of Carfax. If you think of bugs, you think of AI. Is that not what's happening? Apparently. I mean, if you want to do this more formally, Pew's done some public opinion polls. But this is this is telling me we might be approaching crisis territory. There is good news. I think unambiguously the blue screen of death was a software quality crisis, perhaps the archetypical example of one. And we did beat it. Microsoft specifically beat it, right? It was theirs to beat or not. So I'd like to give you a slightly harder quiz than I gave you earlier. How was it beaten? So, and I promise this will be the last engagement we have to do, the last homework I'm going to give you here. If you'd like to raise your hand if you think blue screen of death was beat with better documentation. Okay, no one on that front. Who thinks it was beaten with better architecture? A few people. Who thinks it was beaten with static analysis? A few people maybe know what I like to talk about. I'm going to say yes, actually. Everyone who answered was right. The people who didn't answer were probably right about something else. Because this is defense in depth, right? Like no golden solution is going to do the whole thing. But let me break down a little bit how those factor in. The context here is overwhelmingly the cause was related to device drivers from third parties, right? Not the same vendor as the operating system, but in coordination with them. And what would often happen is memory bugs, which we've made progress on since, and API changes. Also, between the operating system and what the device driver's author expected the API to do at the time, there was some drift there. Now, the reason better documentation was key here is because the sample code originally had bugs already in it. So, the hardware manufacturer, of course, is going to copy the sample code out of the documentation and have bugs in their driver before they've even written their driver. So, they made a really wise move, which is to not have bugs in the sample code and the documentation. And that part of the problem improved considerably. Architecture. This is a little more of a conventional engineering solution, right? They did something nice with blast radius. So it was a lot less common that a single application or driver would crash the whole computer. It would more often crash the application, device driver. I mean, we didn't prevent the bug, but we stopped it from being such a big problem. That's such a huge win. You see echoes of that all over the place, like the Chrome browser's early popularity. Part of it was like, oh, hey, just my tab crashed when the web pages are unstable, not my entire browser. Great. It was worth a lot of RAM for a lot of us. So another one that I didn't mention, a little bonus, error reporting. They began gathering information on which crashes were actually happening so they would understand what triage they needed to prioritize. In the web world now, we have this thing called observability that's very helpful, right? Very similar kind of thing of wanting to know what's actually happening in the world. So I like static analysis, not to the exclusion of knowing what's actually happening in the world or documentation or any of these other things. So to talk about this one, some things that they did while fighting the blue screen of death was they built a driver verifier engine called SLAM. They built something called Slayer, a memory safety checker for C. I love these names. They built Terminator, which proves programs will halt. Now, some of you who have had undergrad computer science might think you can't prove whether programs will halt. And in general, you can't, but recall, they are not trying to solve a problem about all programs in general. They're trying to solve a problem with whether device drivers will halt. And they cleverly realized that within the subset of code that actually runs in a device driver, you often can prove termination. So this all part of the puzzle of fighting blue screen of death was so successful that you have this gentleman, Bill Gates, saying things like even software verification. This has been the holy grail of computer science. But now in some very key areas, driver verification, we're building tools that can actually do proof about the software. So in 2002, the richest man in the world said formal verification was the holy grail. That is a thing that happened. Anyway, you could call it the holy grail. I do like that. But you could also call it extreme measures, right? Like, they're writing all these tools, they're innovating original academic results just so their drivers stop crashing, like, extreme. But it was a crisis. It directly, like, it was foundational to the continuation of the product's success. Behaviors are forced to change under those circumstances especially, right? But speaking of change, now one thing that is absolutely for sure today is that Anthropic is deceptively campaigning to end software engineering to support a $1 trillion IPO. How'd that get there? Okay, this is too dark. What I meant to say was AI is transforming software. Okay, into what? You want me to get on a train? We should be able to talk about where the train is going. I mean, these are pretty minimal expectations. So I'm going to try to fill in what some of my model here. I want to emphasize here, we are not passive. We are not sitting here waiting for some future meteor to hit us. Like, we're the people they are going to ask to build whatever idea it is of the future that they think they have. We are very, very active in this situation. We have the agency. So let's dial up the difficulty of this problem. I've been thinking specifically about like how this affects these kinds of people, though I think what I'm gonna say is going to also ring somewhat with the rest of you. Let's dial it up the difficulty, right? Programming language designers have a very difficult job right now because these people bet sometimes a decade of their life based on what they think is going to work well in the decade after that. Imagine trying to do that in the current environment. It feels like you're being asked to predict the future. Now, I will do a little bit of future prediction for you now. I am an expert in legacy code and also in coding agents. I was building coding agents before they had that name. When people ask great questions like, what's it going to be like when most of your production code is written by agents? Who's going to be on call? I was there. I was on call. But people just as qualified as me have different predictions. So I'm not going to ask you to bet on my prediction. I am going to ask you to make a different bet. I'm only giving you my prediction for transparency, so you know my biases. So how can you design a programming language when people can't even agree on whether code is for people or code is for agents? And especially if people think it's like exclusive, it's got to be all of one or the other. I mean, we kind of know the code is for people part, and also, the machines we knew it was for. But this idea of like the inevitable outcome is code is exclusively for agents. I find it very strange that we would need to respond to this. I suspect agent maxing. It just sounds very suspiciously like what the token vendors want us to do. And I think people who have worked with automation know it, like, if you want it to work really well, you kind of use it in the right places. You're very strategic. So I don't really empathize with what is a dominant narrative in the AI bubble right now, but I realize maybe inside baseball from your perspective, this idea called the dark software factory, where you only talk to your chatbots and maybe Markdown, and you deal in 100% agentic code that those agents are maintaining. So I'm not going to say that this is impossible to build. It's actually like significantly less crazy than it might sound to some of you. I could think of a few situations in which this might be like a reasonable thing to do even. But like to hold this up as like what we should push every single use case in the entire industry, from e-commerce to healthcare to avionics, I mean, I don't think that makes any sense. I think that is likely to have bad results in most environments. So I can't get behind that, right? I cannot in good conscience recommend we hold this up as the direction to go to, as like the one true destination. Like, I don't have it in me. You see, I'm from a place, we have to explain a point here for the travelers here. Okay. The thing about the people in the great state of Missouri is we like to be shown things. It's like our whole shtick. I know some of you flew in, but if you drove, there was a sign that you went by when you come in informing you of this. So don't make me tap the sign. Around here, we don't like to turn the lights off. We don't like to blindfold ourselves unless we have seen really good reason why that's a good idea. So it's only fair that I call my response to the dark software factory model the show me method. Now, very, I think, mundanely, I would claim that code is often working really well for agents to handle for us, and others more to the advantage that we at least read it and sometimes write it too. So I just suggest we continue with that model and handle it on a contextual basis. Recognize there is a boundary between these, but that boundary is being renegotiated over time based on various pressures, right? Like risk, desire for speed, different things have different needs at different times. You may be in healthcare instead of e-commerce, all sorts of factors. And if you are saying, Ray, I actually think more agentic is very good for me, the show me method's got you covered, because your magnet is going to drag you over to this side, and even it is a generalization technically of the dark software factory if you want to go all the way, but I think it's much more likely that you're going to want to stay with a little bit of stuff. There's like critical business logic or something else that is just like, the risk reward is not really, there's no benefit. There's only downside to going full agentic sometimes. You get a lot of leverage off of just a little bit of code. And people say things to me like, well, if we're still doing code, which they have still conceived as some monolithic thing, how are we gonna raise the level of abstraction? Which they're very excited about doing. To which I will say, by using abstraction, which is a primary feature of code. I can't believe we're having this conversation. I know I didn't need to have it with you, but you will probably have to have it. So I simply think we should choose our level of agentic code based on our needs, and that should be okay. Progress doesn't always look like sliding the boundary to the right. Progress looks like a happy system. So how do we improve upon this other than by acknowledging that dynamic? It implies certain things. It does imply that we don't specifically change our languages to be better with agents so they are specifically worse with people. It would imply we don't do that. But also, it would imply, if we want to improve, we're kind of trying to improve it for both. We're kind of optimizing for a lot of things, knowing that we might need to go back, and optionality is good, but I understand this is a little bit of a tough pill to swallow, saying we've got to optimize for both things. So I want to introduce one more component to the diagram, which are tools. So both the agents and people are maintaining the code through tools. And it just so happens they are by and large using the same tools. So clearly, we have one point of leverage where kind of no matter where the trade-off fits, even if the dark software factory people are right and I'm wrong, they're still going to need a tool chain. And if we give them a better tool chain, they'll have better agents. So just to underline this point about how they use the same tools with different interfaces. I know that's a claim. Here's an example of that. Language servers are things that make our editors tick. I know you're probably familiar with these, a lot of you. So they power like IDEs, and the agents don't speak usually to the language server. They speak to the model context protocol server, or something to that effect. And so you think, okay, they have different needs. One needs an LSP, one needs an MCP. But both of those are an interface. And underneath it, if you look at what's actually being called, it is the same kind of tool, you know. So this is what I think, in general, the bet that can't lose if you're uncertain about whether you're doubling down on a future of people maintaining code, which I claim has its place, or not. Simply you go down the stack to the software tool chain. You do what I'm doing. And so then we become very interested in programs that reason about programs. Compilers, linters, IDEs, refactoring tools, static analysis we've established is a much bigger area than is generally thought. And other things, right? These can all help us ask questions about code, visualize it, navigate it, all sorts of things that all parties involved are going to need to be able to do. Programming languages can make decisions that enable tool support better. I think we've experienced this in our career. What is a way I would recommend to enable better tools right now? And I think a great common denominator to zero in on here is formal definitions. Isaac informed us this was Christmas. So, dear Santa, dear programming language designers, software has not been that good of a boy this year. We're trying to get better. And I only want to ask you for three things. I don't want to put too much on you. Define your syntax tree. Think of it like the Christmas tree, if you like. Define your semantics. And work with legacy code. For the particular problems I'm interested in, that is an overwhelming factor on whether I can adopt your new language. If it's an old language with a significant amount of legacy code, okay, you've got that covered clearly, but I really appreciate it when new language designers allow me to work with some dominant pile of legacy code in some way, in terms of, like, you know, introducing it into an application. Some nice to haves here, which I kind of just leave to the designers of how they want to think about that, is simplicity. Simplicity definitely helps analysis. Restrictions can also help analysis. Maybe it's another kind of simplicity, really. But as an example, you know, that's talked about a lot right now, is like sort of Zig and Rust, which I claim are both making decisions that help analysis a lot, because simplicity helps, and also restrictions help. And so I think there's lots of room to explore that space. I'm not trying to impose my vision on that with this whole tool chain argument that I'm trying to give you, even though, you know, I've got my own biases. So I'd like to say, like, if you do these things that I'm asking, defining what your language is in a way machines can understand, I will cheer you on. I hopefully will get to work with you on it. But I want to showcase some people that I think are ahead of the curve. So, you may have heard of this fellow, Richard Feldman. He has a new language called Rock, and its type system, lots about the language is very interesting. If you saw Alexis King's talk yesterday about how we can leverage the most value out of a simple type system, Rock is very much in that school of thought. I'm not going to talk a ton about it, but fast, friendly, functional is the tagline. It has this feature called platforms, right, which is kind of a layer on top of FFI, which is foreign function interface that is very cumbersome. But once a platform for a particular language is implemented, then, okay, now I can make a Rock program that talks to applications in that language. So legacy friendly is covered, and also restrictions, because that one application can only have one platform. That platform says what is allowed to happen in terms of side effects. So you can make statements like, no matter how many Rock dependencies I bring in, if it says the app can't have an HTTP call, it's just not making one. I don't have to search my CVEs to tell if I've got this or that happening. Like, this program is simply incapable of doing this category of action. Like, that kind of stuff, I think this should catch on. not directly related to Rock, but they talk about the design a lot and design of other languages, is the Software Unscripted podcast. Like, if you're looking to get into this kind of area, language engineering, great resources there. Also, I was just speaking of these, kind of subtle trade-offs between these two languages, right? Rock was recently rewritten from Rust to Zig. I really enjoyed Richard Feldman's explanation of why that was. It challenged some of my assumptions. And, sort of wherever you land, I think that that's an interesting piece to read. It was what started my curiosity about Zig, which I understand a lot of you are curious about as well. Another showcase, a little more obscure, a little more crazy, EYG, called Eat Your Greens, by my friend Peter Saxton. Now, this is the code sample. If you're attending this conference, it has ideas you would find interesting, but I'm just going to call out the things I'm recommending that it happened to be doing already. So it's defining a stable internal representation. That's the IR, right? It's very close to a syntax tree. Actually, it predated the language's syntax, like textually. He defined an IR and like a year later was like, okay, fine, I'll add a syntax. So he was really big on this AST story. It's legacy friendly in a totally different way, right? Because it's such a simple language that it's very embeddable, like Lua, but much more embeddable than that. It's trivial to add its interpreter to a legacy application and say, okay, now I have a sound type system that I can build some category stuff on top of this other app. Like, I think this is just a pretty cool idea, and its effects system, again, very easy for you to choose as the developer your own restrictions about what this code is going to be able to do. Talking about type soundness a little, I think a lot of you might know that that's a different and much more specific property than this notion of type safety, how type safe is something. Type soundness means a pretty specific thing, of the order of if type checking succeeds, which in EYG is all by inference, never by saying the types, but entirely inferred. If that succeeds, the program will never crash. The distributed systems people here might inform me that if you hit my computer with a hammer, the program will stop running. I agree, please don't try it right now. I assure you the formalized version of this property is useful and is kind of accurate about what it claims there and what it doesn't. But all error cases within the program must be handled. That has a tremendous impact on just how ergonomically correct your programming habits tend to be. Also, like, it is a mathematical claim, as I say. So we're not arguing about, is this type safe? Like, no, it is or it isn't sound. So this is also a front page feature, right? So if your language is advertising a certain property on its front page, or your application in general, I think my advice is going to apply to both of these, you would like to really know that that's true. Now, I did want to check this, and his language is still pretty experimental, so I don't claim there's any promise that at this point the details have been worked out, right? But it's like, okay, as far as he was aware, it fulfilled type soundness, and it's based on research that should. So that's very intuitive to me. It ought to be type sound, but it's written in Gleam, right, which is a cool functional programming language, and there's no way in Gleam to be like, okay, this language typed as a type sound language. Can you check that, Gleam? Gleam cannot do this for me, right? I like static analysis. I know there's other ways we could think about it if this is the case. But I say we're going to need a bigger type checker. So enter the lean theorem prover, which we're just going to talk about very briefly. But I've been enjoying playing with it a lot. And you notice like they're spelling lean with kind of a backwards E and an upside down A. That is the existential quantifier and the universal quantifier, meaning there exists and for all, sneaking it into the logo there. There's very fundamental things to add to a logic to be able to prove certain kinds of things. If I was trying to prove type sound in a way that's sort of intuitive to you that understands like, okay, it's the inference shouldn't error, if the inference doesn't error, then the eval won't, then you would write something like this language. This is kind of pseudocode here, like, there does not exist a program P such that infer P is not an error and eval P equals an error. Or equivalently, for all P infer P not being an error implies eval P not being an error. You know, so you can say things like this in this language. So theoretically, like all you would have to do to prove EYG's type soundness is port the interpreter from Gleam to Lean, port the type checker, define the operational semantics and type rules, and then prove as theorems your preservation and progress, which are academically the two components of type soundness. It's super easy, barely an inconvenience. Actually, it wasn't that hard because Gleam is just very amenable to being ported to Lean because it's already a purely functional language. And we do have these things called agents now. That helps a lot. And also, it's a very, very simple language, like phonetically simple. So this wasn't as hard as you might imagine. It wasn't, you know, quite super easy. But I did get to a plausible version of all this stuff. And since semantics are the ones that I'm asking people to think about more in their life, this is a little taste of semantics. Semantics, operational semantics specifically, you know, are a family of describing programming behavior that really think of it like an interpreter, like how compilers often have a reference interpreter, except this interpreter is stepwise. Like it's capable of running just one step at a time. Otherwise, if you're written in an interpreter, a lot of the same thing going on. You need to run it one step at a time, and one more thing, it's got a concept called fuel, which is how many steps am I allowed to run the eval for? Like every eval comes with an expiration date, and the reason is that like an arbitrary interpreter might not terminate, and you know, theorem provers like stuff to terminate to the point where they like usually enforce totality, right? That the program will halt or it won't just accept it. So to be able to do provery things, you do those tweaks, and otherwise, you know, Haskell-y syntax aside, you're talking about an interpreter. So my conclusion here is EYG is sound in theory based on the research that it's built on, structural typing and all that, but it's not sound in practice yet. You do not have to trust my formalization strategy because the process produced a one-line reproduction. There is a program that uses the fix built in, which is a fixed point combinator. It is a way to define recursion in simple languages. So it's the same as the Y Combinator, by the way, not the venture capital firm, the real one. And so this type checks as an integer. It evals as a type error. Type sound language, this is a bug, which is great, because then we can fix it, right? So yeah, that's reported. I believe as we handle a few of these probably simple fixes, we will ultimately succeed in proving that EYG is type sound, because by design, I believe it is. So what we've seen here is that like pretty profound results, more than is generally understood, can be established statically. Formal verification, like I love testing, usually the most practical thing to be doing, right? But formal verification can tell us not just about the cases we test, but about all possible inputs, even about such a complex object as for all possible programs. And if you want to start to unlock this world of power, I would suggest define your semantics. That's a nice first step here. Let's talk about just defining what all this stuff is supposed to be and do. Another showcase I'd like to do, right? Man of the hour here. Zig defined a formal grammar. I appreciate it. The grammar is simple. I appreciate it. Makes all the stuff I'm trying to do very easy, relatively, right? And an AST library is bundled with it. So if you're using Zig, making Zig code that manipulates Zig code in a very sound way that the compiler would agree is the right way to implement Zig code in this version and all that, like super easy, barely an inconvenience, for real this time, right? So loving that. The interop story, like the legacy code friendly, again, they've prioritized this in unprecedented ways by putting a C++ compiler inside of the Zig compiler, which is just some mad scientist stuff. Like, and they've bundled into this maintain it with Zig slogan. If you got a big C or C++ app, like maybe just replace your build tool, which like I'm usually not happy with on those code bases anyway, with like Zig's your builder now. And then if you choose to migrate some of your code to Zig, it'll sort of seamlessly allow you to do that as much as little as you want. Like, these are general strategies, which I think is like really good for legacy code maintenance. So like, those are some of the first things that impressed me about Zig. I'm sorry, I know you're sitting right there. I'm sorry, you're gonna blush a little. He said, focus on debugging your application rather than debugging your programming language knowledge. This challenged my assumptions, honestly. Like, this sort of changed how I thought about the Rust, debate. As I've said, like, both things are valid, but like, simplicity, especially with sort of strategic safety measures, like, there's a real strategy going there. So, major Zig code bases include Tiger Beetle, which is a financial, don't jump ahead. Major Zig code bases include Tiger Beetle, it's a financial transactions database. Ghost UI, which is a terminal I use every day. And, okay. Isaac, how much time do we have?
We have 8 minutes, roughly.
Okay, don't call the cops. All right, so, a couple months ago, we had this headline, Anthropic's Bun Rust rewrite merged at the speed of AI. Bun is a TypeScript runtime and compiler. It's gaining a lot of popularity. It's like an NPM replacement. I know you guys love NPM, so you'd really be interested in like a better version of that, is what I've heard. And subtitle here, million lines of Rust code merged in gargantuan commit. Which is like just not really the sort of information you expect to see in the register. I especially didn't really expect to see that like before an explanation was provided to Bun's users. But 2 months later, there was an explanation to Bun's users, which like ultimately some saw this as some kind of slight against the Zig community because they chose to use a different language, but like, it's probably more a slight to the Bun community, to be honest, but it's not really my business either way. But there was some fallout to this. I don't know. I met Andrew yesterday. Like, I don't know him well. Close as I can tell from his harshest critics, his singular flaw is that he's sometimes too honest. Now, okay, there's a time and a place for everything, but as I outlined pretty thoroughly in this thing a few days ago, like, I'm just more concerned at this particular moment in time with the people not who are being too honest, but who are being too dishonest. I think that is a priority for my life right now. So I wrote this little rant. It's actually a pretty large rant called Zig Creator Calls Spade a Spade. Anthropic Blows Smoke. Haha, fun. A few of my friends see it. Oh crap, the Zig, the EYG creator, Peter Sachs, actually threw it on the Orange site. And 4 days ago, it was the #1 on Hacker News, much to my chagrin. So, he has managed to take revenge on my finding his type soundness bug by bringing the other Y Combinator to defend what I was doing with his first Y Combinator. I don't know, this is genius. But, a lot of detail in what I said there, but it was a non-explanation. I outlined why this was a technical explanation for a decision, non-explanation on that merit. Unstated business reasons are really the only reason there would be. And by the way, every technical decision should be based on business reasons. So if you are not naming business reasons, there are always unstated business reasons. So you have not explained any technical decision if you are not relating it to business reasons. But there are some pretty compelling ones here. And the question on everyone's mind is, could they have made Zig work? And this is a fundamentally unuseful question with all this drama now. We'll never know. It's done. That's what I'm here to say. The only way we would know is if someone were to rewind 2 months and, okay, so obviously that's what I did. I forked Bun. Welcome to Project Bunsen, keeping Bun in Zig, the one thing no one involved wanted to do. To do what Anthropic couldn't, debug their own code base. Behold the Bunsen burner. The flames will burn the bugs out of Bun. See, I have climbed to Legacy Mountain. I have learned from the great sages. Marianne Bellotti taught us to kill it with fire, and fire is how Bun is toasted. The metaphor's getting away from me, but I challenged myself to find 3 months worth of memory bug fixes in Bun in a week, which is about 48. I could see why that would be annoying. So I had one dev, one agent, no experience with the code base, and I had learned Zig the previous day. How hard could it be to find 3 months worth of memory bugs? So basically my process is investigating the past 3 months in Zig, surveying 48 memory bug fixes that occurred in that time. I prioritize high churn code because that's where bugs tend to accumulate. I derived conventions from the past fixes. Any fix is a missed convention. I wrote custom linters, not off-the-shelf linters, using that handy Zig AST support. And then I also fuzzed with address sanitization and thread sanitization, which actually was quite successful despite the fact that they said they were already doing it. So I caught 50 existing memory bugs that were still latent in the Zig code base. And I one agent, right? Like good old Sonnet and Opus. I'm not using a $100,000 agent fleet like they did with their solution. I'm not using a super secret Mythos model that's banned by the government or whatever we're doing now. Like, just sort of standard legacy code stuff. You could have all done it. I'm not as smart as I sound because you can throw a rock and hit bugs in this code base according to people who work on it. That's what I'm getting from that. So, yeah, I did catch 50 existing memory bugs. It's not the question is why didn't they? And obviously they could have. They just didn't. It wasn't an engineering priority. So for my purposes, hand wavy, case closed. Another thing I'll do that they didn't do is cite the state-of-the-art research on converting memory unsafe code to Rust. Why did they not mention this? Why does no model lab ever mention the prior superior art when they talk about how they are translating one language to another? I don't know why they don't. Might take the wind out of their sails if you knew Tractor goes to safe Rust, not just the unsafe Rust that they did. I don't know what their motivations are, just that they aren't saying them. But one thing I do know, for today's purposes, before my experiment, they had already conceded my point. Because by saying they need the borrow checker, waving the white flag, our Mythos model can't catch a use after free, they are saying AI wasn't enough. We need the language toolchain. I agree. So this sounds interesting to you, especially if you're working with an emerging programming language and you'd like it to be adopted in trust-critical applications. I'd love to talk to you. This is what I'm doing full-time now. But I just want to leave you with, we have a choice. The future of vibes or the future we define. Thank you.